Hello, I'm Reggie York, and this is a presentation on finding a statistic for your data, particularly using a system that I have for such as that. Let me tell you what this presentation is about. It's how to use my guide for finding a statistic. It is designed for the human services with special attention to the evaluation of outcome, and it is a limited guide. There are a lot of statistics that will not be included in this particular guide, but I have found that this guide covers the vast majority of situations where a typical human service professional will be wanting to evaluate outcome. So here are a couple of assumptions. First of all, you know what statistics do. You know what statistical significance is. You know what the value of P means. And you understand where to look to determine if your data are statistically significant. There's some things you need to know in order to use this guide. First of all, how many variables are in your analysis for which you're seeking a statistic? At what level is each variable measured? Ordinal, interval, or nominal? Whether the data are from paired samples or independent samples. Paired samples are when you have things like pre-test and post-test scores where the scores of a particular person are matched. Also, how many categories are in the nominal variable if you have a nominal variable in your analysis. Let's talk about reading the first chart. This tells you which chart to use, and then we'll move on to the other charts to be used here. Let's go back to the beginning. That should be helpful. Finding a statistical measure for your study is the very first chart. That's table A. You'll notice how this is structured. You have a column that says how many variables are in your analysis. Only one, two variables, or three or more. Next question, at what level are the variables measured? You have some cells that are shaded, which means there is no relevant question there. But in these cases, there is a relevant question. That then leads you to the third column, which tells you which table to use. For example, if you have only one variable, you'll use table B. If you have two variables, both variables are nominal, you'd use table C. But if ordinal, table D. If interval, table E. You can say that if you have three or more variables, there is no table for this. However, you are instructed that you can use multiple regression analysis if all variables are measured at the interval level. Okay, now let's look at the next table, the one where you're seeking a statistical measure for examining the nature of one variable. Excuse me. So what do you want to do? Do you want to describe the variable? At what level is the variable measured? If it's nominal, means you can go to frequencies, percentages, or the mode would all be appropriate to describe a nominal variable. Ordinal variable, however, you can use all of these above plus the median and the range. If you have an interval variable, all of the above plus the mean and the standard deviation. Moving down to examining the differences among the categories of the variable, which means, of course, you have a nominal variable. If there are two categories, then the binomial test would be appropriate. Three or more categories means the chi-square one sample test would be appropriate. Now let's move along to table C, selecting a statistical measure for examining the relationship between two nominal variables. First question, are the data drawn from paired samples or independent samples? Here the first line has to do with paired samples, the second line independent samples data. Are both variables measured as a dichotomy, meaning in a yes, no, or just in two categories is what that means. If the answer is yes, then the McNear test would be appropriate. If the answer is no, then we have to say, sorry, but no measures in this system will fit. That is the system of different statistics that I have assembled for this particular guide. If you have data drawn from independent samples, you can see here, and the answer to Does at least one variable have at least 3 or more categories? If the answer is yes, meaning that you do have at least 3 or more categories, then the chi-square test for significance would be appropriate. The contingency coefficient for the strength of the relationship would be appropriate to help you with practical significance in determining whether the differences in the categories or what is the strength of that relationship between the variables you are examining. If it is not true that at least one variable has 3 or more categories, then the chi-square test for significance would be appropriate for determining statistical significance. And the phi coefficient for the strength of the relationship, the phi coefficient, in other words, would be something you could use for determining the strength of the relationship, the magnitude of your results. Let's move down to now a special file that's particularly appropriate. Table D, selecting a statistical measure for examining the relationship between two variables where at least one is measured at the ordinal level. I hope by now you've gotten a little bit of the hang of this, of how to read this table. At what level are the two variables measured? If you have one ordinal and one interval, you get all the way over here and say, sorry, but no measures are appropriate in the system. However, if both are ordinal, you can go over here and see that the Spearman rank correlation coefficient would be appropriate. If one is ordinal and one is nominal, and you have two categories with paired samples, then this test would be appropriate. The Wilcoxon matched pairs signed ranks test. There are more categories, with two categories, independent samples, the Mann-Whitney-U test. Moving down to the next category, if we have 3 or more categories in the nominal variable and paired samples, you have Friedman two-way analysis of variance. Independent samples would lead you, however, to this particular test right there. Okay. Now let's look at the situation where you're looking at the relationship between two variables and at least one is measured at the interval level. The first line you can see actually is a duplicate of the previous one, but sorry, no measures in this system fit. But if both are interval, then the Pearson correlation coefficient would be appropriate. If you have one interval and one nominal variable with paired samples with two categories in the nominal variable, t-test for paired data would be appropriate. If it's independent samples, however, and you have two categories, t-test for independent samples would be appropriate. If you have paired samples but 3 or more categories in the nominal variables, you do not have a measure in this particular system for that. But independent samples with 3 or more categories, you have analysis of variance, often referred to as ANOVA, as an appropriate statistic. Okay, now I want to move to a special table that not only tells you which statistic to use, but also the particular Excel file that I have created, which you could use to put in your data and find the results. You, of course, will need to have one of those files, and if you're in my course, you will have that available. If the research design is the one group pretest post design with a single score to represent the pretest rather than an array of scores, pretest scores, but you have an array of post-test scores. That is to say, you couldn't match the pretest score with a post-test score for each individual. You were not able to do that. If you are able to do that, then there is a different test that would be appropriate. If you cannot do that, then you could compute the mean score of the pretest, compare it to the array of post-test scores that you have to determine statistical significance. So if your level of measurement is interval, then the one sample t-test would be appropriate for that situation. Here is the Excel file that you could use, if it's available to you, to put in your data and look at the results. This is an explanation here in the notes category of what I've just told you. If you have the one group pretest post-test design interval, and this is the one group pretest where you have, as you can see, use this if you can match each person's pretest score with her post-test score. So that's the situation. Different from here, in this situation, you can match each person's pretest and post-test score with interval data, Paired t-test would be appropriate. And this is the Excel file, York paired t-test comparing two sets of matched scores. That is the name of the Excel file you can use. Moving right along, I think by now you've gotten the hang of it. If you have the one group pretest, post-test, nominal data, or dichotomous, binomial test could be appropriate. Comparison group, as you see over here, it says use this to compare the gain scores of two groups of persons. You've computed a gain score for your service group, and you've computed a gain score for a comparison group that did not have your service. And you want to know if the service group, the treatment group that is to say, had a significantly higher gain score than did the comparison group that did not have your treatment. Here the independent t-test would be appropriate. Here is the name of that file that you could use for that particular situation. As we move on down, the AB design, that is a single subject design, by the way, and you have nominal and dichotomous data. The binomial test would be appropriate, and you can see the explanation over here. Use this if you are comparing an array of treatment scores, each measured as a dichotomy, with a proportion of baseline scores that are positive. So it's the same as the binomial test. It's the same as the before and after when you have a dichotomous variable comparing a treatment group and a service group. But what you're doing is looking at the baseline. Imagine the baseline scores as the before and the treatment scores as the after. Both baseline and treatment scores are put into only two categories, either positive, negative, recovered, did not recover, or something of that nature. If you can imagine that particular situation, then this particular test would be appropriate, and this particular Excel file would be appropriate for you. The limited AB design, you're using the one sample t-test like you did before. Here is an explanation. If you're using the AB design with interval data, the standard deviation approach would be appropriate. Here's the name of that particular file for that. Use this design when you have enough baseline scores to represent a trend, but the trend does not show a significant slope. I say that a trend, 3 or 4, I'd say 4 at least, probably baseline measures is appropriate for saying that you have enough data to determine, to establish a trend in your baseline. Okay, I think that we're done here. Now the next step is simply to get that particular Excel file, if you're using this particular one, and enter your data. I hope this was helpful to you.